Okay, problem number 4. So, it looks like Sage and Sophia, right, have now involved Julia in creating this huge exercise plastic ball, right? And I actually looked this up. There are such things. I thought they were just for gerbils and hamsters, but nope. No, as you see in the picture, this is a great form of exercise. So, in her calculations, Sage has apparently figured out that the volume needed, okay, so the volume needed is 33.5 cubic meters. What should the diameter measure to the nearest meter? Okay, so you should be able to see that this is a work backwards problem because we have the volume and we're working towards the diameter. Okay, so again, always think what formula is involved. Well, again, this is a huge exercise ball, so you are thinking sphere. So volume equals 4/3 pi r cubed. Okay, now again, we want to make the substitution with the only number that we have in the problem, and it is the volume, right? So we are going to substitute, right, the volume in for the volume. So that is 33.5 equals 4/3 pi r cubed, right? And again, the only variable in the problem is the radius. And if I could figure out the radius, could I figure out the diameter? Of course. I would just double it. So now really what you want to do is use your algebra. Okay? So there's different ways that you can go about solving this. Thinking of the techniques that come in handy for Algebra 2 next year, we really like to, when we're working with problems that have fractions in them, really get rid of the fractions. It makes life a lot easier. And it's really easy to get rid of fractions, right? Don't be scared of those fractions. All we really have to do is we have to get rid of that denominator. So if you think about this, if I multiply this side by 3, of course, what I do on the one side of an equation, I have to do on the other. But that's where those 3's, right, will divide out. 3 divided by 3 is 1. And then I won't have fractions anymore. So then I just want to pick up my calculator and do the 33.5 times 3. Okay, follow that down to 100.5, right? And then over here on the right, I just have 4 pi r cubed, right? So in order to solve for r cubed, really all I have to do is divide by 4 and divide by pi. And you can do that together. So you can divide by the 4 pi on each side. Now, you do have to be careful, right, that if you're using your division key that you put, right, you want to divide by the 4 pi, right, together. Or, once again, new calculators, you can use your alpha y equals fraction bar and then not have to put the parentheses. So that's totally up to you, whichever way you want to do that, right? So if I hit divide in my calculator, I'm going to put those parentheses around the 4 pi. Okay, and it looks like to me I have this number 7.997. 5, oh, that's a bad 5. I slipped a little bit there. 5, 3, 5, 8, 9, ... equals r cubed. Okay, now we've undone r squared by taking the square root. Have we ever undone a cube? Well, think, if a square root undoes a square, what do we think undoes a cube? Yes, a cubed root. So now what I want to do is I want to take the cubed root of both sides. And that looks like this. Cubed root, cubed root. And that's going to give me my r. All right, now how do I get a cubed root in my calculator? Well, if you go to your math button, down to number 4, it has the cubed root. And then you can just retype, or what is easy, if you just go up and copy and paste the answer you have in your calculator, it'll take the cubed root, which is going to be 1.99979 dot, dot, dot. That's quite enough, right? And it says, right, what should the diameter measure to the nearest meter? Okay, so if I look at this, right, I just want to do what? If this is the radius, how do I get the diameter? I want to do what? Yes, multiply by 2. 2 radii equal a diameter, in which, of course, you're going to get 3.999 dot, dot, dot. And the final answer, we're going to round that. That's really so close to 4 meters. Right? You wouldn't notice the difference between that and 4 meters. So they're going to need 4 meters, right, of diameter for their plastic human exercise ball. Okay, so again, I hope you found that to be helpful in determining how you did with your solution. Action Jackson, signing out.